Welcome to NASA Edge.
An inside and outside look
at all things NASA.
And we're going to be talking about the future of aeronautics today.
Yes, a very exciting topic.
Speaking of education, we have a cool segment coming up here.
We do.
We do have, there's a lot of engineers here at NASA Langley who mentor kids. We bring in a lot of students from university levels and even high school. One engineer, Gary Qualls, was fortunate enough to bring in 10 students this summer to work on a very cool project.
Yeah.
Tell a bit more about that.
Well, actually, what they're doing is sort of an accident avoidance system for these remote helicopters.
Right.
So they actually do collision avoidance and things like that using really interesting technology.
Right.
And one of the students happens to be Amanda, who has been a field reporter for us.
That's right. That's right.
So let's take a look at the clip. Yes, we're here with Gary Qualls, and I understand you worked with a bunch of students this summer. What actually did you guys work on?
Well, we've had a group of 10 students working on a small robotics lab. We've got a combination of ground vehicles and some aerial vehicles. We've got a blimp. Mostly we've been focusing on some quad-rotor helicopters, which are small helicopters with 4 motors that keep them up. And the students have been teaching them how to fly around in a volume and interact with each other. And that's the whole idea of the lab, is to find out how these kind of interactions will work best. And they are situations that could vary from small planes in real airspace to robots flying around indoors. So to get this kind of work done, the students have had to look at computer programming. These kind of robots have code on board that's controlling how they work. We use a lot of open source software for that. All the robots are talking to ground computers that have software running on them that the students have written. Most of the 10 students at this point have written their own control programs from scratch to control different vehicles, either ground vehicles, simulated airplanes flying around the county, and also these quadrotors flying around inside the lab. We've got electrical engineering students, computer science students, we've got psychology students, aerospace engineering students, mechanical engineering students, and they're all having to work across several different disciplines. They're all writing code, they're all checking electronics, they're all soldering stuff together, finding out what doesn't work. Because solving these kind of problems is different from the normal kind of problems you get in a lab at school. In a lab or a homework assignment, you're given everything you need to be able to solve the problem. And those are not the kind of problems that you get out in the real world, and it's not the kind of problems we're giving them here in the lab. You know, we're giving them problems where they have to do a lot of research online or go to the library, start conversations with people who are writing the open source software they're trying to use. Those people will change the software to help us out and do our job. So it's a very interactive, very cross-discipline project. To see them, toward the end of the summer, kind of come into their own and feel very comfortable with electronics, very comfortable with software they've written, and be able to work together as a good team. I mean, it's a really good feeling to see everything come together.
We got to get one of those quadcopters for this office here.
And for Adam, he could airlift in new diapers. Like you can have him bring them to you, and you can hold your hands up, and the helicopters drop the gloves on, and you're good to go.
There you go.
For the record, he uses gloves to change diapers.